algebraic method for resultant. We can use algebra to obtain the resultant force and its line of actions as follows. 1. Choose a convenient reference point. And move all forces to that point. This process is depicted for a 3-force system in figure shown here. In this picture, M1, M2, and M3 are the couples resulting from the transfer of force F1, F2, and F3 to point O. For example, we transfer all forces to point O and replace them with a force and a couple. Replace F1, F2, and F3 with force couple system. At O. The next 2. Add all forces at O to form the resultant force R and add all couples to form the resultant couple MO. To form the resultant force R, and add all couples to form the resultant couple MO. MO, we now have the single force couple as shown in this picture are sigma F and MO sigma M. Consider this picture for this stage. The next and the last stage is 3. In figure, find the line of action of R by requiring R to have a moment of MO to have a moment of MO about point O. Note that the force system of this picture, consider this picture for this stage. Note that the force system of this figure are equivalent to previous system of forces as shown here. This is equals to this picture. Principle of moment is the next section. The principle of moments as we said before, these three process algebraic method summarizes in this equation. At first, R equals to sigma F MO equals to sigma M or equals to sigma F T, and R T equals to MO. The first two of these equations reduce a given system of forces to a force-coupled system at an arbitrarily chosen but convenient point O. The last equation specifies the distance d from point O to the line of action of resultant R, and states that the moment of the resultant force about any point O equals to the sum of moments of the original force of the system about the same point. This extends very known theorem to the case of non-concurrent forces system. We call this extension the principle of momentum. For concurrent system of forces, where the line of the action of all forces passes through a common point O, the moment sums about the point is zero, like for example this picture. Consider this picture. For a concurrent system of forces, as we said, concurrent where the line of action of all forces pass through a common point O, the moment sum sigma MO about that point is zero. Thus, the line of action of the resultant R sigma F, determined by the first of equation 210, passes through point O. For a parallel force system, select the coordinate axis in the direction of force. If the resultant force R for a given force system is zero, the resultant of the system need not be zero because the resultant will be a couple. The three forces in the figure shown here, for instance, have a zero resultant force but have a resultant clockwise couple M equals to F3D. This because F2 and F1 has no momentum on point O.